All right, here's number 92B on redox reactions in an acidic solution. So we got these ions. Again, these would probably be like potassium. This is called the dichromate ion. So it'd be something like potassium dichromate, maybe sodium chloride. You have to have those ions in solution from some ionic compound that's dissolved. First thing, figure out individual charges of elements. Oxygen, again, doesn't change very often. It's a -2 times 7 is a -14. This whole thing has -2 charge, so this must be a +12. Well, each individual chromium then is a +6. So notice chromium's going from a +6 to a +3 individually. There are 2 chromiums on this side, 1 on that side, so we'll have to balance that eventually. Chlorine obviously here is a -1, and any diatomic element is a 0 charge. So we can do oxidation or reduction first. Let's do our oxidation. Doesn't make any difference. I'm going to say oil. Oxidation is losing electrons. So that is going up in charge. That's your chlorine going from a -1 to a 0. So we're going to go Cl negative, turning into Cl2. Since the atoms are not balanced, make sure we balance the atoms. So there'd be 2 of these ions forming, this would be chlorine gas over here as a diatomic element. Going from a -1 to a 0, oxidation is losing. So this is losing 1 electron per chlorine. So 2 of them total. Remember, instead of putting -2 electrons here, we put +2 electrons on that side. There's no oxygens, anything like that, so we don't have to worry about putting hydrogens in. Good to go there. Reduction, oil rig. Chromium is being reduced, but you have to include the whole thing that chromium is a part of. So Cr2O7 -2 going into Cr +3. Again, first thing, since there are 2 chromiums and 1 there, the element that's being reduced here we need to make sure is equal. Charge is going from a +6 individually to a +3. So that is 3 electrons that each chromium is gaining, but there's 2 of them, so that is going to be +6 electrons. So this chromium is gaining 6 electrons. It's getting them from this chlorine ion. Electrons are being transferred from here over to that. Next thing here, I need to make sure that the overall charge is equal, or you can do waters. Since there's only oxygens on this side, you could put in waters and say, okay, I know I'm going to put in 7 H2O over here to get 7 oxygens, which means there's going to be 14 hydrogens. So there must be 14 hydrogens because we're in an acidic solution. Remember, there's excess H+ ions in acidic solution, excess OH negatives in basic. This should equal out the charge. When I say charge, we have a -2, and -6 is a -8, and +14 is a +6 on this side. 2 times +3 is a +6 on that side. So the charge is equal. They don't cancel. Not a +6, -6. Charge is equal. +6 and +6 over here. Make sure electrons lost are equal to electrons gained. So we need to multiply top one by 3. So this becomes a 6, 3, 6. Combine things together. The only thing that will cancel in this case will be electrons. So your reactants would be 6 Cl negative plus Cr2O7 -2 plus 14H plus forms 3 Cl2 plus 2 Cr plus 3 plus 7 H2O. There's your overall reaction.